welcome to another live wells training class. We are so happy you are here. We got an '07 Pontiac Grand Prix, right?
Yep.
With a 3800 engine in it, and it works just fine. But it's a great example for the tech line calls we've been getting a lot of lately.
Exactly.
Yeah, we've been getting a lot of calls on this where the dual fans are operated with 3 relays.
Right.
Right? Okay, and the question is first, what the heck is wrong? And our answer is, this is how the system works.
Right.
And that's what we're going to answer today. But in order to do that, we're going to have to do it. We're going to have to first find out how the system works.
Right, exactly.
Right? So let's go do that.
All right, let's do it.
Let's go do that first.
All
okay.
right.
All right, here we are. You had a quick peek of the car, of the vehicle. But before we get started and we explain how this system functions, let's talk about the question for the t-shirt.
All right.
Yes, for the t-shirt. If you'd like one of these, you need to answer this correctly. And we're going to do it a little bit different this time. Instead of leaving it a wide open blank, you know, fill in the blank question, we're going to do a technician A, technician B, neither or both, just like you're taking an ASE test.
Exactly.
Just like the test. Okay, here's the question. On this circuit right here, you can see that we got battery plus, and we have 2 blower motors with the equal resistance, all right, and ground. Okay, in this scenario right here, technician A says motor 1 will spin faster than motor 2. Technician B says both motors will spin at the same speed. Okay, who is right? A, B, neither, or both? Okay?
All right.
All right.
It's a good one.
If they say both, I'm going to question whether or not I asked this question correctly, okay?
All right.
All right, so it's top 3 here. I'll give you that hint, okay?
Perfect.
All right. All right, so Mike, why don't you go through how this system functions?
Right, yeah,
right?
and that's one of the major calls we get on the tech line is they open up their fuse panel thinking, okay, my cooling fans don't work, I just maybe have a blown fuse or a bad relay.
Right.
So they open up the fuse panel and the first thing they see is fuse 1 and fuse 2 for cooling fan 1 and 2.
Right.
They see they have 2 fans, but then they look a little further and find out that they actually have 3 relays in there. Cooling
3
fan
relays,
relay 1, 2, and
2
3.
fans. How does that work?
Exactly.
Okay.
So that's their question. What the heck do I do now, right?
Right.
So then it usually turns into a discussion of how the system works. So why don't we go ahead and do that?
Right.
So if we pull up the diagram here, you'll see.
And that's where we always have to start.
Exactly,
You
yeah.
have to have the diagram.
Yeah, because how do you know what to test on this circuit if
Right.
you don't know what you're looking
You
for?
got to have a map.
Right.
Okay.
So in our first diagram here, I've taken everything out that's not needed to run the fans on low speed. We're going to start on low speed. So you can see we have battery plus at the top. The power comes in through fan number 1 fuse, fuse number 29, that's a 30 amp fuse, and goes to our fan relay right here.
Okay.
Then if we go ahead and command the cooling fans on by the PCM grounds our relay and turns on our fan 1 relay.
Okay.
That's going to then send power down to our cooling fan, the left side cooling fan. So from there, our power comes through our cooling fan, and now we need a path to ground at some point to make that fan work.
That is correct.
But this is where it actually becomes very interesting in this type of circuit. Our power flows through the fan, through fan relay number 2, and you can see fan relay number 2 right now is connected inside there. In the rest position, fan relay number 2 is acting as a kind of a pass-through device. It's letting the current flow through that relay, and then onto a splice down to the right side cooling fan.
Okay.
From the right side cooling fan, then the power goes, or the ground, then goes back to G100 there.
Right, it goes to ground. It finds its way to ground.
Right, so this circuit is wired up in what's called a series circuit, where both fans, I guess it could be referred to as, some people call it a daisy chain circuit, something like that.
Yeah, and that's what we have here too.
Exactly. So power starts at the top from our battery plus, goes through a relay to 1 motor, and then instead of it going directly to ground, it goes through the other fan and then to ground. So what makes these fans operate then at low speed is because the series circuit, by the laws of the circuit, according to the resistance level of the fans, they operate at a slower speed, just like a daytime running light.
Okay, that's a good example.
I guess the best way to break it down would be the more loads or the more motors or the more resistance you have in the circuit, the less amperage you're going to have. That's Ohm's law, right?
Right. That is
So
correct.
the less amperage you have, the less something moves, so the less the motor's going to move. So if you have two motors in one circuit, they're not going to spin as fast if you had two motors in two separate circuits.
Right.
So by doing that, by having two motors in one circuit, they can control the fans on low speed.
Mm-hmm.
So if we want to control our fans on high speed, let's get to that diagram now. The high speed power comes in, battery positive again, goes to both of our relays, fan 1 fuse, fan 2 fuse, and then down to the relays. The computer will then control or command the high speed relay control. It'll turn that on and ground fan relay number 2.
And that's where the difference occurs. Remember
Right.
that we did not activate relay number 2 at all. at this
Exactly,
point.
exactly. So by activating that fan relay number 2, it's actually going to be sliding this over and sending, creating a path for the left cooling fan to get to ground without having to go through the other fan.
Right.
If we follow the power, it'll have this low speed fan controller on as well.
Mm-hmm.
It'll turn on fan relay 1, power will flow from that to the motor, the left side fan. It'll go down back through fan relay 2, which has now been turned on,
Which is now active.
and then it goes directly to ground.
Right.
So it's not having to go through that other motor.
So now it's like eliminating this one motor and going directly to ground.
Exactly.
So we're not going to two, so the
Right.
load is half as much.
Right, exactly. So now that motor is able to spin faster.
Right.
So if we want to go to our fan relay 3 here, this relay is just for high speed. So when this relay is turned on at the same time as fan relay 2 is turned on, they're wired in a splice right here.
They're kind of daisy chained together, if you want to call it that.
Yeah, yeah. So the computer commands that on, turns fan relay 3 on. That'll send power down to our right side cooling fan, which then goes directly to ground as well.
So now it has a separate, it's like a separate,
Exactly.
without the one motor being in there.
Exactly. So now on high speed, both fans are able to get a direct power feed. They can both get back to the battery on their own instead of having to go one through the other.
Right.
So that's how they're able to operate at a faster speed.
Hmm. Now we have a supply voltage to each one,
Exactly.
and that's what makes the difference.
Right.
Is separating, it's virtually what it's doing is it's separating the supply voltage.
Right.
Right?
Yeah.
Instead of being dependent upon one wire, now we have separate wiring for each one.
Yeah. Yeah. That's a good point. If we were to do a voltage test and we wanted to check our supply voltage on high speed, we would see 12 volts at each of the power supplies to the fans.
Right.
If we were to check that on low speed, we'd see something else.
Yeah, that's what we're going to do right now, aren't we?
Right, yeah, depending on how the
So
circuit
now
is.
we got a pretty good idea how this works.
Right.
Now the next step is, okay, how do I test it? And when it doesn't work on low speed, how do I test it when it doesn't work on high speed? You
Right.
know, what's going on here? Do I have a bad relay? That type of thing.
Exactly.
And so let's go to the car and do that.
Okay, let's do it.
All right, let's have some fun.
All right. Okay.
All right,
So-
all right. Where are we going to start this diagnosis?
Right. Well, first of all, I just wanted to say that this doesn't only apply to this Grand Prix.
Okay.
You know, we looked across multiple different vehicles, different makes, manufacturers. A lot of vehicles, even up to, what do we look at, 2014, they're still using this 3 relay design.
Right, still the same setup.
So I just wanted to clear that up first. Okay.
Okay. All right, so where do you want to begin?
Well, let's start with doing some testing.
Okay.
Let's start with high speed. Let's start with the fans not working at all.
All right.
And now what we can do here is, I already have the key on, and we got the scan tool hooked up. We're going to control the fans with the scan tool.
And they could also control it through the relay, right?
Exactly, you could.
Okay, so you jump across 30 and 87, and
Right.
you got, you know,
Yeah,
you're
you
doing the
would-
same thing that the computer does.
Right.
virtually. And by the way, we do have a video out on that that we put out years ago, and we'll put a link to that
Yeah,
in case you
for
haven't
sure.
seen it.
The only downside to just jumping the relay, jumping 30 to 87, is you don't know if the computer is actually able to ground the control side of the relay.
Right, that is correct, and that
Where-
could be a failure.
Right, where this
Yes.
full function, any full function scan tool should be able to control that.
Right.
Okay, so why don't we go ahead and, if I didn't have fans working, the first thing I would check is see if I have power to them.
Okay.
So if we go to our diagram again, just as a reminder, we should see power on each of these legs right here. Remember, they both have their own power supply back to battery voltage. So each one should read roughly battery voltage when the fans are turned on, when the
And-
relays are energized.
And on high, you're working a series or a parallel circuit here.
Right, exactly.
Okay.
Yep, they're wired up in parallel.
All right.
So it looks like we're having
Some issues with our connection. Let me check here.
Oh, we'll go back to high-speed fans. And what I'm going to do is I'm going to first hook up on our power side. So on our white wire, we'll go on, actually, sorry, the light blue wire will go on the right fan, light blue wire, and we'll see where we're at for our voltage. And I have the other lead of the meter right here on ground. And now we should be able to get some high-speed fans.
You can see our scan tool screws up too, just like yours.
Likes to take its sweet time here. There we go. So the relay clicked on it kicks on the low speed fans first actually, then kicks in high. And there we go, we're running on high, you can see already. 11.78 volts, that looks good. I'm just gonna swap over to the other side. Same thing, okay, perfect. Both of our fans are coming on high and they're both being supplied with battery voltage like we expected.
And that is how it should work with a parallel circuit.
Exactly, just like testing
Brake lights.
anything, yeah.
Right.
A solenoid, whatever, it's wired
Okay.
up in parallel.
Right.
Let's go ahead and do a voltage drop test now. Now in a parallel style circuit, you want to drop all of your voltage, all of your power across the load. So across the fan, we want to see a full 12 volt battery voltage drop.
Right.
That's the way these things work. So I'm going to go ahead and hook into our ground wire here. I'm going to go on the, which wire was this now? The gray wire, I believe, out of the first fan. Yep, okay. So I'm going to hook into there, turn it on again. And now I do need to swap our clamp over to the other side because we want to measure how much voltage we're dropping. So now if you look, again, we're on the opposite connection here, but we're dropping our full voltage across the load. And that's what we want to see. In a parallel circuit, you should drop all of your voltage across the load.
Right.
Just like testing anything that we normally do.
Right.
Okay, well, should we show the amperage now?
Yeah. Let's
Okay.
look at that. That's when it gets interesting.
Yeah, exactly. So we have an amp clamp here. Put it on the 1 millivolt 10 milliamp scale because we're just trying to read a lower amperage scale. And hook up around our wire down here. Go ahead, zero it out. And you want to go ahead and kick those back in.
Okay.
And we'll measure amperage reading on these. There we go. And it looks like it evens out to about 0.95 there. And now, we can go ahead and turn it back off. Now when I'm using the amp clamp, I'm kind of lazy when it comes to figuring out the math. I don't like to move the decimal points or get out a pen and paper and do the conversion from the voltage to the amperage. What I do is look at that and it read 0.95. I use kind of some logic and figure out, well, it's not going to be 0.95 amps.
Right, it's gotta be
gonna
more than that.
It's not going to be 95 amps, so it must be in the middle at 9.5.
9.5. Yeah, if you're wondering where to move that decimal point
Yeah.
and all that kind of stuff, just use simple logic.
Right, exactly.
You got to be somewhere in this area.
Right, so I would say the left side fan here is running 9.5 amps to make it run. So now we can go ahead and do the same thing with the right side.
Okay.
Go ahead, turn it on. And I would expect to see somewhere similar to that.
Should be close.
And it'll settle down 1.25. I would call that 12.5 amps. So that's actually quite a difference there.
You got a 3 amp difference. Now, why would you have that?
Well, there must be a difference in resistance between the two fans. A
Right.
higher resistance, a higher amperage.
And because they're parallel,
Right, exactly.
right? They're both, parallel means they both may be drawn from the same source, but they have their own separate tap to that source,
Right.
okay?
Yep.
All right.
So, and remember now
Oops,
that
there we go
these,
again.
remember these two fans, when they're in parallel, have different amperages. When we get to the low speed, we'll show you the difference there.
Right.
Well, why don't we go back to the diagram quick and just show how this, the real key to the high-speed circuit. And what I guess the main key to this circuit right here is going to be this fan 2 relay.
That absolutely is. Once you understand how that relay works,
Right.
you understand the system.
Right. So right now, that fan 2 relay is being energized. It's creating a path for the left side cooling fan to get to ground. If we switch this over to our low side diagram, you can see in the rest position, so this diagram written in the rest position, which is...
Isn't that interesting? Here's a wiring diagram that's written in the rest position.
Hey.
Remember our dilemma with
that
the other
cam
Pontiac
sensor?
with the cam
Yep.
sensor, and we're getting 11 volts instead of 12,
Right.
like the diagram said.
Yeah.
That one was written in the run position,
Right.
which is very unusual.
Right.
Most diagrams are written in the rest position,
Right,
like
and
this one.
that's the way this one is. So in the rest position, fan relay 2 is able to pass the current for a low speed fan. When we turn it on high speed like we just were, it turns the relay on, switches over, and provides a different path for the current to flow. Without this relay in there, the system wouldn't function right.
Right, it wouldn't work like it's supposed to.
The left side
it'd
fan
be
wouldn't
impossible.
work at all. The right side fan could still function. So that's something to watch for. If you get a high speed problem where one fan's working, the other one's not, take a look at that fan relay too. You might have an issue in there.
Right.
So
Yep, good stuff.
okay, let's go on to the low speed now. Bring up our diagram. And remember, our low speed fan wired in series has a single power supply, a single ground supply for both of the fans. They are daisy chained together, run in series through again that fan relay 2, and then back to our other fan and then to ground. So if you had a problem with no low speed operation at all, if
Right.
high speed worked on one side maybe, or I guess if high speed worked on both, it's possible.
Sure.
But if you have a low speed operation problem, if you have a problem with either one of these fans on low speed, the
Both are not going to work.
right, that's
Yes.
what I was trying to
Yeah,
say.
there you go.
If you have a problem with the left fan, there's no way that the right fan gets powered up. The power has to flow through there and get to the right fan to turn it on. If you have a problem with the right fan, there's no way for the left fan to get its ground path. They have to work off of each other. If one
Yep.
doesn't work, the other doesn't work.
It's just like the Christmas tree light thing.
Right.
Right? So you got one bulb that goes out and all 50 are out.
Yeah, that
right?
could be a problem.
Yeah, so you got to go in there and pick out each, you got to find the
Right.
one that's out.
Right, and
Because one out means all out.
that's kind of a downside to a series circuit, is if you have one problem, it wrecks the entire circuit.
It is. And, if you had brake lights like that,
Sure.
you're losing all your brake lights.
Yeah,
you know.
that's a problem.
That's very dangerous. And like you said, that we talked earlier about daytime running lights
Yeah.
are, in series.
Right.
If you want to
Yeah,
explain
yeah.
that.
This diagram right here could be drawn up just like a daytime running lights diagram, where instead of the cooling fans being here, this would be your high bulbs, your high beam bulbs would be right here. And instead of a fan relay, it'd be your daytime running light control would send power through each of the high beam bulbs in series to cut the amperage to them, so that then they would
Right.
operate at a dimmer
Yeah.
brightness.
Yep. Cool
Okay,
stuff.
why don't we go ahead and show the voltage now. So if we check our voltage here at our left side cooling fan, that's going to be our 12 volts, because remember, that's going to be supply voltage from battery positive to the cooling fan. We should see 12 volts there. But now in a series style circuit, we're not going to drop our full voltage across the load, because we still have to power up this load. So depending on the resistances in these, it's going to drop that set amount of resistance, the set amount of voltage. I would expect to see probably about half of the voltage drop across the first one and half across the second one. So if we want to have a test like we just did with our high-speed fan, where we get a full voltage drop, we would want to check between our battery positive again, where we just were before, and then let's measure the full system's voltage drop across both loads. So then we would want to measure at our black wire, and I'll get back to the diagram here in a second. We'll measure at our black wire right here. So with the system powered up and the fans running, we'll drop our entire system voltage across both of these loads right here. So we add up the resistance, drops it across the load, and we'll show that. You want to go ahead and turn on high speed.
Okay.
There we go, as soon as these fire up. You can see we're dropping battery voltage across both of the loads. Now what we can do is take this and hook it in to the, what wire was that? To the gray wire. And this will be, oh, we're on high speed right now. You want to turn it on low? Sorry. We have to go to low speed for this
How do
part.
you get to low?
Yep.
Exit.
So we're going to hook into the gray wire now, and we're going to see the voltage drop just across one of the loads.
We're getting there.
Got to wait for the scan tool to catch up with us.
Yes.
So I'm hooked in right here right now. So before, when we were doing our parallel circuit, we would have dropped our full voltage across this load right here. Now we're only going to drop roughly about half of it because we still have to power up our right side, and that's the way a series circuit works. So if you are doing testing on this thing and you want to find out a voltage, you want to check your voltage reading, say like right here, you want to see how much voltage is powering up this fan, you're not going to expect to see 12 volts there. You want to see 6 volts or 6.5 or 7 or whatever is being dropped across that first one, subtracted from your battery voltage. So it can get tricky when you're doing series circuit diagnosis because you could think that you have a problem there reading only 6.5-ish volts. And that could really throw you off if you didn't realize that this was a series style circuit.
Mm-hmm.
You can see on our meter here, across our first load, we're dropping about 6.7, 6.6 volts across that first load.
You should be very close on the second.
Right. If I go ahead and hook this up, I'm going to hook into that same spot, that light blue wire, which before was our 12 volt feed into our right side motor. If I hook this up to there, you'll see our right side motor right now is only being powered up by 6.8 volts.
Right.
And that's what it's doing to
Change the speed.
Lower the speed, exactly.
Yeah, lower the speed.
Now this seems like kind of a old type of design. You know, we were talking about MOSFETs last week and how we can control things.
Right. And you can see in the future that it'd be much wiser to have a MOSFET in here to control it. And not only do you can do an infinite amount of speeds. You don't just have to have fast and slow.
Right.
Yeah.
And then if you have a MOSFET controller for each fan, you could turn them both on at different speeds. And then if one fails, you don't have both failing.
Opens up all kinds of variables.
Exactly. It's a much better designed system, I think,
Yep.
than using 3 relays.
Much better. And it's just a little bit too expensive at this point.
I think so
and
too.
They haven't come down in price enough where engineers are incorporating them and everything.
Right.
You know, maybe on high-end cars, Bentleys or something like
Maybe,
that,
yeah.
you'll have different speeds like that.
Yeah, they'll have cooling fan controllers, that kind of thing.
Yep.
One other thing that I wanted to show here that is interesting when you're testing a series circuit, remember when we used our amp clamp on the parallel circuits when they were on high speed, we saw an amperage difference. We saw about just under 13.
We had an indication that right fan is starting to fail.
Right.
For some reason, it's drawing more amperage than the left fan.
Right, exactly. So if we do that same hookup, I have the amp clamp in there. Oh, sounds like they just turned off. The scan tool keeps kicking out.
All right.
Well,
retry.
Once we get the fans back on.
He was saying you weren't going fast enough. That's all there is to it.
Maybe there's a timer built in. You'll see that our amperage actually in a series circuit is consistent through the entire circuit.
Right.
So right now we're at 0.42, so about 4.2 amps.
Right.
If we go over to the other side, I would expect to see the exact same thing. Now remember, we're using the inductive style clamp, so there's going to be a little variance in that.
But you're not going to see
It's not going to be a 3
drastic
amp difference.
4.14. It is the same.
So it's exactly the same.
Yep.
And that's a really good lesson. In a series circuit, your current or your amperage is going to be consistent through the entire circuit.
Right.
No matter how many loads you have in there, it'll be consistent.
Because
So,
Ohm's law says you must
Exactly.
add those two resistances together.
right,
That kind of thing.
exactly. So
Remember Ohm's law? We got a training class out on that too. We'll put a link down there
Boy.
too on that
Ohm's
in
law,
case you missed it.
series
That was when I
circuits.
was arguing with Mike
Oh,
Mike Dale that you can't use Ohm's law to fix a car. Well, here I am again.
yeah, we're
I
fixing
was
a
wrong
car.
again.
We're using the laws of series circuits, parallel circuits,
Right.
Ohm's law.
Absolutely. So great,
Yeah.
good stuff.
And
Anything
actually,
else?
that brings us right into the answer of our question that we
Oh
asked.
yeah, let's do that.
Now remember, we were asking, that was a series circuit drawn there. We're both, we can go ahead and turn these
Oh
off.
yeah, sorry.
Both of our loads, both of our fans had the same exact resistance.
Mm-hmm.
So you would add that resistance up, and then both fans would spin at the same speed because it's a series circuit.
So the correct answer is
The correct answer is Tech B.
Tech B. So did anybody send that in?
I think so. Let's take a look. Let's see what we got here. Looks like this NCPD FSB said Tech B. I believe your name was Drew. So you're
So-
right, Drew. Great.
Hey, Drew. Good to
this
see
is
you
Tech
here.
B. And then also if we go over on the other one here, it looks like Terry commented in and also said Tech B.
All right, Terry,
great, two
thank you.
answers.
Thank you for using the comments too. I
Yeah.
appreciate that.
That-
We had some issues. I hope that worked better for you.
So if you want to go ahead and bring up my email address, if you guys want to send out your mailing address and your t-shirt size, we'll make sure to get one sent out to you guys right away. And
All right,
I think
great
that's
lesson.
about it.
Good stuff.
So-
And geez, we do have to know the difference between series and parallel
Yeah.
circuits, don't we?
Yeah, if you tested this thing and saw only 6 volts at a fan, you'd think there's an issue in your power supply, right?
Absolutely. Right.
So,
Great stuff.
okay,
Anything else you want to add?
that's about it for me.
All right. Without you being there, we would not be here. We sure do appreciate it. And we'll see you again next time in the Wells Tech Garage.
We'll see you then.
All right. Let's